Celiac Disease by Danielle Lesourd, Jill Tymko, and Sammy Potvin.
Hi, my name is Sammy. I'm going to be your student nurse today. What can I call you?
Betty.
Betty. Nice to meet you, Betty. So what brings you into the clinic today?
I've just been feeling so tired lately, and my stomach is really bloated, and I have a lot of gas, and I've had some diarrhea lately, and I've had a little bit of weight loss as well.
Okay.
Yeah. I know my mom has celiac disease, so I'm just wondering if it maybe could be something like that. What is celiac disease? Celiac disease is also known as celiac sprue and gluten-sensitive enteropathy. It's an immune-mediated disorder that is triggered by the ingestion of gluten-containing grains such as wheat, barley, and rye.
Causes and risk factors. It's estimated that 1 in 100 to 1 in 200 people in the general population have celiac disease. People with the disorder share the major histocompatibility complex 2 allele, HLA-DQ2 or HLA-DQ8. There's an increased risk for people with type 2 diabetes, other autoimmune endocrinopathies, first and second degree relatives with celiac disease, and individuals with Down syndrome and Turner syndrome. It results from an inappropriate T-cell mediated immune response against gliadin, which is a component of gluten, in genetically predisposed people. When an individual ingests gluten-containing grains, the gliadin is broken down in the stomach by an enzyme known as pepsin. The gliadin can then be further broken down in the small intestine.
Lining the walls of the small intestine are tiny finger-like projections known as villi. Normally, the nutrients from digested food moving through the small intestine are absorbed through the villi and cause no abnormal reaction. In celiac disease, the gliadin is absorbed through the villi into a layer of tissue called the lamina propria and binds to an HLA-DQ2 or HLA-DQ8 complex, which is a protein on the cell membrane of an antigen-presenting cell, such as a dendritic cell. The gliadin is presented as a foreign antigen on the HLA-DQ2 or HLA-DQ8 complex. The helper T cells see the antigen and secrete cytokines, which cause an immune response and activate cytotoxic T cells and B cells. This causes antibodies against the gliadin to form, which are proteins. This immune response causes the release of enzymes transglutaminase, which modifies the gliadin by introducing a more negative charge. Therefore, the gliadin will bind more readily to the HLA-DQ2, HLA-DQ8, and elicit a stronger T cell response.
This whole process is characterized by the secretion of pro-inflammatory cytokines, which cause local inflammation to the villi. This local inflammation reduces the villi's ability to absorb nutrients by decreasing the surface area of the villi. This response is a disruption of homeostasis as the body is not absorbing the nutrients it requires. This lack of nutrients being absorbed in the small intestine is related to the symptoms Betty has been experiencing, such as bloating, flatus, fatigue, and weight loss. Fatigue is also a result of iron deficiency. Diarrhea is related to the inflammation of the small intestine wall, which is impairing the ability of the nutrients from the food to be absorbed.
So as a recap, for our key concept homeostasis, inflammation of the villi disrupts the homeostasis of the small intestine by inhibiting its ability to absorb nutrients. For our key concept proteins, the HLA-DQ2 and HLA-DQ8 complexes predispose individuals for celiac disease. Gluten is made up of the glycoproteins gliadin and glutenin, and antibodies created during the inflammatory response are proteins. In cell membranes, protein carriers can be embedded in the cell membrane.
So Betty, I see here that you've been recently diagnosed with celiac disease following a blood test and an endoscopy procedure. So the doctor's recommending that you avoid foods that contain gluten, and it's also recommended that you take a vitamin and mineral supplement because of the malabsorption in the small intestine.